Welcome to another Mathnificent Conversation featuring multiplying rational expressions. It's your nerdy math bestie Lex. Grab your pencils and let's go. Before we get started, we got to go over a little background information, which I like to call mint green tea. Some of this might look very familiar if you've already watched the multiplying fractions video, because remember, rational expressions are just fractions. They follow the same rules. So remember, in math, you can multiply anything. There's nothing called a like term when you're multiplying. Whatever two things are or two factors are, you can go ahead and multiply them. We multiply rational expressions straight across, just like we do fractions. So we multiply the numerators over multiply the denominators. A hint, you don't have to do this. You can do this at the end. But for me, I like to factor everything before I multiply them together. Always check to make sure the final product is completely simplified. And please remember, if a factor does simplify to 1, you must acknowledge it in your final answer. And if you don't know what I mean by acknowledge it, take a look back at the simplifying rational expressions video, or just catch on as I go through each of the examples. All right, let's get started. All right, our first example, we've got two rational expressions that are being multiplied. How do I know to multiply them? We have a dot in the middle, and if you're at this stage in math, we use a dot more often than we use any other thing to identify multiplication. So my first rational expression, I've got x minus 1 over x plus 3. X minus 1 and x plus 3 are both prime, so I can't factor them further, times x plus 2 over x minus 5. Both of those are also prime, so those can't be factored. So I'm going to go ahead and multiply straight across. You'll notice I'm not actually multiplying them. I'm leaving them in factored form. And I do that because if anything simplifies, I need it in factor form. Most teachers will not require you to multiply these back out. Leaving them in factor form is typically best practice, or what's practiced most by teachers. But I don't have anything that simplifies to 1, so my answer is finished. If your teacher required you to multiply it out, we'd have x squared plus x minus 2 all over x squared minus 2x minus 15. And again, in the rest of the examples, you won't see me multiply them out, because in my courses or when I'm teaching, leaving it in factored form is the form that I prefer. All right, our next example, we've got 3x over x minus 5 times 25 minus 5x over 9x squared. Before I begin factoring, I'm going to flip around negative 5x plus 25, because I prefer everything in standard form, because things like to hide, factors like to hide when things are not in standard form, and sometimes students miss it if you aren't aware or looking for it. Now I'm going to go and factor what I can factor. 3x is prime. X minus 5 is prime. I can factor out a negative 5 in this numerator, and I'm left with x minus 5 all over 3 times 3, x times x. Everything is factored completely. Now I'm going to go ahead and multiply straight across. You're going to notice when I'm multiplying straight across, I'm going to move things around and multiply them in a different order, which is fine. 3 times negative 5 times x minus 5 all over 3 times x times x minus 5. Okay, my numerator and denominator have common factor of 3, common factor of x, common factor of x minus 5. That leaves me with negative 5 in the numerator, 3x in the denominator. I have to acknowledge the things that simplify to 1. Now, because I still have an x in the denominator, I don't have to acknowledge the x that simplified, but I do have to acknowledge that x cannot equal 5 because a factor of x minus 5 simplified to 1. And this is our final answer. Okay, in this example, everything appears to be in standard form, so I can go ahead and factor everything first. X squared minus 1 is a difference of 2 squares. It factors to x minus 1, x plus 1. X plus 3 is prime. X squared plus 8x plus 15 is a quadratic trinomial. So I need two numbers that multiply to 15 but add to 8, 3 and 5. So it's going to factor to x plus 3, x plus 5, all over. X plus 1 is prime. Now that everything is in factored form, I'm going to go ahead and multiply straight across. You might notice me rearranging some things. So we have x minus 1, x plus 1. I'm going to put x plus 3 in the front, x plus 5 all over, x plus 3, x plus 1. We have a common factor of x plus 3, common factor of x plus 1, so those simplify to 1. So we're left with x minus 1 times x plus 5. Acknowledging x cannot equal negative 3 or negative 1. And that's our final answer. All right, let's go to our next example. I see 4 minus x squared. That's not in standard form. I'm going to flip it around, but at the same time I flip that around, I notice a leading term of negative 1, which alerts me that I should probably go ahead and factor a negative 1 out of the numerator. Again, this is places where things hide. So this is going to flip around a negative x squared plus 4. Okay, now I'm going to go ahead and factor. This is a sum of two cubes. It's going to factor to x plus 2, x squared plus 2x plus 4 all over x minus 5 times negative 1. Quadratic trinomial, which means I need two numbers that multiply to 10, positive 10, but add to 5. There are none, so it's prime. Okay, in the bottom, I can factor a negative 1 out because this leading term is negative. And I'm left with x squared minus 4, which I know is a difference of two squares. I'm just going to make a note to myself that in the next step, this is going to be x minus 2, x plus 2. This guy here. So now I can multiply everything together, rearrange some things if I need to. Negative 1, x plus 2, x squared plus 2x plus 4. Let me remind you all, if you've watched the sum of two cubes video, This guy is always prime. You don't need to check to see if it factors. X squared plus 5x plus 10 all over -1, x plus 2, x minus 2, x minus 5. Common factor of -1, common factor of x plus 2. Everything else is prime. So our final answer, x squared plus 2x plus 4 times x squared plus 5x plus 10 all over x minus 2, x minus 5, acknowledging x cannot equal -2 because it's simplified to 1 and we can no longer see it.
Go. Why are teddy bears always full? Why? Because they're stuffed.
All right, we're starting in a little bit more complex, but not really. We'll take it a step at a time, and it should flow just like the rest of them. Everything looks to be in standard form, so I'm going to go and do our regular routine, which is factor everything. This guy here isn't going to be factored. It needs to be expanded, which means that this exponent will distribute to both of those. So 2 squared is 4, and x squared is x squared, which I'm going to write as x times x because we want everything in factored form. X plus 5 squared is x plus 5 times x plus 5. X squared plus 10x plus 25 is a quadratic trinomial. It's also a perfect square trinomial, but you can factor it normal, two numbers that multiply to 25 but add to 10. So that's going to be x plus 5, x plus 5. All over 2 is prime, x times x times x. X plus 5 is prime. I can factor a 2 out of here, and I'm left with x squared minus 16. But that's also a difference of 2 squares, so I'm going to remind myself that that is going to factor to x minus 4x plus 4 in the next step. So we have 4 times x times x. I'm going to change the 4 to a 2 times 2, so it's completely factored. X plus 5 times x plus 5 times x plus 5. All over, I'm going to rearrange some things in the denominator. 2 times 2 times x times x times x times x plus 5, x plus 5, x minus 4, x plus 4. Okay, common factor of 2, another common factor of 2, common factor of x, another common factor of x, common factor of x plus 5, and another common factor of x plus 5. I've simplified all my common factors to 1, and everything I'm left with is prime. So my final answer is x plus 5 all over x times x minus 4 times x plus 4. I don't need to acknowledge that x can't be 0 because I still have an x in my denominator, but I do have to acknowledge that x cannot be -5 because all of the x plus 5s in the denominator have simplified to 1. So it still needs to be acknowledged, and that is our final answer. All right, we've reached our last example, so let's go ahead and knock this one out. Everything seems to be in standard form, so I'm going to go ahead and start factoring. I can factor a 5 out of this term, and I'm left with x squared minus 1 That's a difference of 2 squares, so I'm going to note above it, it's going to factor 2, x minus 1, x plus 1 in the next step. X plus 2 is prime. 2x squared plus x minus 3 is a quadratic trinomial, but a isn't 1. So remember, I'll do some scratch work over here. 2x squared plus x minus 3. This is a, b, c. I need to multiply a times c. So 2 times negative 3 is negative 6. Two numbers that multiply to negative 6 but add to b, which is 1. That's going to be 3 and negative 2. Then I divide both of these by a. So divide by 2, divide by 2. Bottom to top, bottom to top. But this one simplifies to negative 1 over 1. So 2x plus 3, x minus 1. If you need to go back and watch the video, please do so. There is a factoring quadratic trinomials with a greater than 1. So here we have 2x plus 3, x minus 1. I can factor out a 3x, and I'm left with 2x plus 3 all over 10 factors to 2 times 5 times x. Let's multiply everything together. Might rearrange some things. 3 times 5 times x minus 1, x plus 1, 2x plus 3, all over 2 times 5 times x plus 2, x minus 1, 2x plus 3. Common factor of 5 simplifies to 1. Common factor of x simplifies to 1. Common factor of 2x plus 3 simplifies to 1. So we're left with 3 times x minus 1 times x plus 1 all over 2 x plus 2 x minus 1. And see, I missed, we also have a common factor of x minus 1. It's a good thing sometimes to double check your answer at the end, because sometimes there's so much going on you forget common factors to simplify. So we're left with 3 times x plus 1 all over 2 times x plus 2, acknowledging x cannot equal 0, x cannot equal negative 3 halves, and x cannot equal positive 1. And that is our final answer. I hope this was helpful. Remember, you are magnificent and you're brilliant, and I'll see you in our next video.